100 meters beneath the Jura Mountains, a ring of niobium-titanium superconducting magnets stretches for 27 kilometers in total darkness. Liquid helium pumps relentlessly through the system, driving the ambient temperature down to 1.9 Kelvin. It is a mechanical trench engineered to be colder than the deepest regions of interstellar space. Inside this ultra-high vacuum, beams of protons are accelerated until they reach 99.9999991% of the speed of light. They travel the 27-kilometer circuit 11,245 times every single second. This is the Large Hadron Collider. It is the most complex machine human beings have ever constructed, built for a single, uncompromising purpose: to smash the fabric of reality apart and examine the debris. At 4 specific points along this subterranean ring, the beams are forced to cross paths. The resulting collisions generate temperatures 100,000 times hotter than the core of our Sun, concentrated in a space infinitely smaller than a single grain of sand. For a fraction of a nanosecond, the violent conditions of the early universe are recreated. Detectors, massive cylinders of iron, specialized crystals, and silicon trackers the size of cathedrals capture the aftermath. They take 40 million three-dimensional photographs a second, mapping the chaotic spray of decaying subatomic shrapnel. The mathematics governing these interactions, known as the Standard Model, is the most successful scientific theory in human history. It dictates exactly how matter and fundamental forces must behave. It is an airtight, mathematically perfect framework that has accurately predicted the outcome of particle physics experiments for half a century. But buried within petabytes of raw collision data, a persistent shadow has emerged. When researchers analyze the decay of specific heavy particles, the rigid symmetry of the universe begins to fracture. According to the flawless equations of the Standard Model, everything must balance. Momentum entering the collision must equal the momentum exiting the collision. When a particle breaks apart, its remnants should perfectly account for the original energy, like a shattered glass where every shard can be weighed and accounted for. Yet, in the silent, supercooled depths of the detectors, the universe is doing something else entirely. The sensors are registering a deficit. Physicists refer to this phenomenon as missing transverse momentum. It is an invisible weight on the cosmic scale. Energy is simply vanishing from the collision point, carrying physical momentum away into an unseen domain. At the same time, tiny fractions of particles are choosing decay paths that drift away from the predicted mathematical equivalence, leaning toward one side of the equation, when nature demands they remain perfectly centered. This is not a mechanical glitch. It is not a rounding error. It is a whispering anomaly that has survived years of relentless cross-examination by thousands of the most brilliant minds on the planet. We built a flawless mirror to reflect the fundamental truth of the universe, and the reflection looking back at us is distorted. The bedrock of modern physics is cracking under the immense pressure of these tiny, impossible deviations. The data filtering through the global computing grids suggests the presence of unseen forces, or perhaps entirely new, heavy categories of matter operating just beyond the edges of our perception. If the Standard Model is incomplete, then our entire understanding of reality is merely a temporary illusion. The rules that govern the burning of stars, the formation of galaxies, and the atomic structure of our own bodies are fundamentally flawed. We are sitting on the shores of a vast dark ocean, realizing that the currents pulling at the water are generated by something we cannot see. The data continues to stream out of the collision chambers, cold and indifferent to our confusion. Human biology is a localized survival mechanism. We evolved to perceive a very narrow band of reality, optimized entirely for navigating the macro-physical world of predators, gravity, and seasonal weather. Our senses tell us that matter is solid, that time is a constant flowing river, and that empty space is, by definition, empty. This is the great biological illusion. We are prisoners of our own neurology, locked inside a sensory framework that lies to us about the fundamental nature of the cosmos every single second of our lives. When you touch a stone, you are not feeling solid matter. You are feeling the electromagnetic repulsion between the electron clouds of your skin. and the electron clouds of the rock. You have never actually touched anything in your life. You are a ghostly lattice of atomic forces, hovering infinitesimally above the surface of a world built almost entirely of empty space. To break free from this cognitive prison, we had to invent mathematics. We had to build machines that could feel the universe where our hands could not, and see the architecture of reality where our eyes were blind. The standard model of particle physics was not handed down as a divine revelation. It was violently extracted from nature over a century of agonizing trial and error. It is the culmination of our assault on the unknown. It is a mathematical fortress that successfully united three of the four fundamental forces of nature: electromagnetism, which lights our cities and binds our atoms; the strong nuclear force, which holds the cores of stars together; and the weak nuclear force, which governs the slow radioactive decay of matter. The math underlying this model is not a series of suggestions. It is an ironclad dictatorship of symmetries. It states that for the universe to exist in a stable form, a brutal, uncompromising balance must be maintained. If you change a single variable, if you adjust the mass of a single quark by a fraction of a percent, the equations collapse, predicting a universe that rips itself apart before the first stars can even ignite. This model is so precise that it predicted the existence of the Higgs boson decades before we had the engineering capability to find it. It told us exactly where to look, exactly how much energy it would take to tear it out of the quantum vacuum, and exactly how it would decay. When the Large Hadron Collider finally cornered the Higgs in 2012, it was hailed as the ultimate triumph of human intellect. We had deciphered the source code of mass itself. We believed we were reading the mind of the universe. But this intellectual triumph bred a dangerous arrogance. We assumed that the fortress was complete. We assumed that the empty spaces on our cosmic map were just waiting to be filled in with variations of what we already knew. The anomaly hiding in the decay chambers of the European Organization for Nuclear Research shatters that assumption. To understand the terrifying implications of this anomaly, we have to look at how we actually observe these collisions. You cannot photograph a subatomic particle. They are unimaginably smaller than the wavelengths of visible light. Instead, physicists must operate like forensic reconstructors at the scene of a catastrophic explosion. When two protons collide at near light speed, they annihilate each other, converting their kinetic energy into raw mass according to the principles of mass-energy equivalence. For a fleeting instant, a shower of heavy, unstable particles is born. These particles cannot exist in our cold, low-energy universe. They decay almost instantly, transforming into lighter, more stable particles, which in turn decay into even lighter particles, cascading outward in a microscopic storm of radiation and matter. The detectors surrounding the collision point, behemoths of engineering like Atlas and CMS, are designed to catch these secondary and tertiary particles. They are composed of distinct layers, like a mechanical onion. The inner layers are lined with millions of silicon pixels, which track the curved paths of charged particles caught in a massive magnetic field. The shape of the curve tells the computers the momentum of the particle. The outer layers are dense calorimeters built of lead, steel, and liquid argon, designed to force particles to crash into them and deposit all their energy. By measuring where a particle stopped, how it curved, and how much energy it dumped into the wall, supercomputers reconstruct its identity. The system generates an apocalyptic amount of data. Millions of collisions occur every second. If CERN were to record every single event, the data storage required would exhaust the entire world's hard drives within days. Therefore, the machines are equipped with hardware triggers, brutal algorithmic gatekeepers. These triggers are programmed with the rules of the standard model. They scan millions of collisions a second and instantly throw away 99.99% of them, classifying them as known physics. Only the collisions that look interesting, the ones that produce rare, heavy particles, are saved to the server farms. We are trusting our algorithms to know what is important. We are trusting our current understanding of physics to filter reality. And even with this aggressive filtration, the shadow remains. The anomaly manifests in the decay of specific particles known as B mesons, or beauty quarks. According to the flawless symmetry of our reigning theories, when a B meson breaks apart, it has a choice. It can decay into an electron or it can decay into a muon. A muon is simply an electron's heavier, more unstable cousin. The universe is mathematically obligated to be entirely indifferent to this choice. The equations dictate a perfect equilibrium. For every beauty quark that decays into an electron, another must decay into a muon. The ratio must be exactly 1:1. This principle is called lepton-flavor universality. It is a foundational pillar of how we understand quantum mechanics. If you break this symmetry, you break the standard model. For years, the sensors at the LHCb experiment have been quietly registering a deviation. The B mesons are not decaying equally. The universe is showing a preference, leaning toward the creation of electrons over muons. The ratio is not 1:1. The cosmic scales are unbalanced. Simultaneously, the missing transverse momentum continues to haunt the highest energy collisions. When the sensors map the debris, calculating the trajectories and masses of every piece of subatomic shrapnel, they find that the momentum entering the crash does not match the momentum exiting it. Something is escaping. In the absolute vacuum of the detector, energy is bleeding away, striking nothing, interacting with nothing, and simply vanishing from our physical ledger. This is where the true existential horror of physics begins. These are not mathematical errors. The data has been cross-referenced, calibrated, and subjected to the most rigorous statistical torture imaginable. The deviation persists. It is as if we have meticulously charted the currents of a great ocean, perfectly mapping the tides and the winds, only to realize that the water is inexplicably draining away into an invisible abyss beneath the seafloor. The universe is interacting with a ghost. There is a mechanism, a force, or a category of matter operating entirely outside human comprehension. It does not emit light. It does not reflect radiation. It does not care about the electromagnetic force that binds our biology. If this anomaly holds, it means our fortress is built on sand. It means that the forces that govern the stability of matter, the very rules that allow atoms to form and hold together long enough to create conscious life, are incomplete. We are suspended in a cosmos that is secretly governed by a dark architecture we cannot perceive, influenced by heavy, invisible mechanics that could redefine the fate of the universe. The comforting rigidity of the standard model is dissolving, revealing a chaotic, uncharted wilderness just beneath the surface of reality. We thought we had reached the end of physics. Instead, we have merely reached the edge of our own sensory and mathematical limitations. The universe is vastly older, colder, and infinitely more alien than our equations led us to believe. If you seek the truth in the dark, subscribe and join us on this journey. To understand the sheer scale of what is leaking out of the collision chambers in Geneva, you have to visualize the mechanics of the impact. Imagine a violent, high-speed collision between two perfectly spherical objects moving on a flat surface. When they strike, the debris must scatter in a way that respects the original momentum. If a massive fragment flies off to the left, an equal amount of mass and velocity must recoil to the right. The combined vectors of every single piece of shrapnel, when added together, must perfectly reconstruct the original state of the objects before the crash. This is the conservation of momentum. It is not merely a rule. It is the physical bedrock of cause and effect. When the supercomputers at CERN reconstruct the decay of these heavy subatomic particles, they map the trajectories of the debris with agonizing precision. They measure the recoil, they calculate the angles, and when they add the vectors together, the equation does not close. A massive chunk of the momentum is missing. It is moving outward, passing straight through the densest electromagnetic calorimeters ever engineered by human hands, without leaving a single trace. It is like watching a building explode, carefully weighing every shattered brick and twisted steel beam, only to realize that a third of the building's mass simply walked away invisible. The energy is not destroyed. The mathematics of thermodynamics forbid that. The energy is being carried away by a proxy, a ghost, a particle that fundamentally refuses to interact with light, with magnetism, or with the nuclear forces that bind our physical world together. We are forced to confront a terrifying possibility. The Large Hadron Collider might be successfully manufacturing dark matter. For decades, the concept of dark matter has haunted the periphery of astrophysics. It is often misunderstood as a cosmic void or as empty space. It is exactly the opposite. It is an overwhelming, crushing, physical presence. To grasp the immensity of this invisible architecture, we must temporarily leave the microscopic subterranean rings of Europe and cast our gaze outward, into the freezing expanse of the local galactic group. In the late 1970s, observational astronomers began meticulously tracking the rotational velocities of spiral galaxies. A galaxy like our Milky Way or Andromeda is a swirling disk of hundreds of billions of thermonuclear furnaces, bound together by the collective gravity of their own mass. According to the laws of orbital mechanics established centuries ago, the speed at which a star orbits the galactic center should be entirely dependent on the mass enclosed within its orbit. The stars clustered densely near the luminous core should whip around at tremendous speeds, while the stars scattered along the dark, desolate outer rims should move at a sluggish, decaying pace. It is the exact same gravitational mechanic that dictates why Mercury tears around the Sun in 88 days, while Neptune takes over a century and a half to complete a single cold orbit. But when telescopes measured the Doppler shift of the light emitting from those outer galactic rims, the data returned a physical impossibility. The stars at the extreme edges of the galaxies were not slowing down. They were orbiting at the exact same terrifying velocity as the stars near the core. The entire galaxy was spinning as a single, rigid disk. The mathematics here are merciless. Based on the visible mass of the galaxy, every star, every nebula, every black hole, and every cloud of interstellar dust, there is simply not enough gravity to hold the structure together at those speeds. The outer stars are moving so fast that the centrifugal force should violently rip the galaxy apart, flinging billions of suns out into the dead vacuum of intergalactic space like water violently expelled from a spinning tire. Yet, the galaxies remain intact. They do not shatter. The only physical explanation, the only way the equations of gravity do not disintegrate, is if the visible galaxy we see is merely a tiny, luminous core embedded deep within a colossal, invisible sphere of heavy matter, a dark halo. And when astrophysicists calculated the required mass of this unseen halo to keep the galaxies from tearing themselves apart, the numbers were paralyzing. Visible matter, the protons, neutrons, and electrons that make up every star, every planet, and every biological organism in existence, accounts for barely 15% of the physical mass of the universe. The remaining 85% is dark matter. We are not the main event of the cosmos. We are a rounding error. We are a rare, luminous contamination floating in a vast, cold ocean of invisible mass. Our entire perception of reality, our entire periodic table of elements, is nothing more than a localized anomaly. The true universe is dark, heavy, and completely indifferent to the electromagnetic radiation we rely on to see. For years, the scientific consensus held tightly to a comforting hypothesis. Physicists theorized that dark matter was composed of weakly interacting massive particles. They called them WIMPs. The idea was elegant. These particles were believed to be heavy, sluggish relics left over from the thermal bath of the Big Bang. They would be entirely devoid of electrical charge, meaning they would never emit or reflect light. They would flow through the Earth, through our oceans, and through our bodies by the trillions every single second, completely unhindered by the atomic spacing of our flesh. The only way we could ever detect them would be if, by pure statistical chance, a single WIMP happened to score a direct head-on collision with the nucleus of a normal atom. To catch this microscopic impact, humanity engineered monuments to silence. Deep beneath the Gran Sasso Massif in the Apennine Mountains of Italy, shielded from the chaotic rain of cosmic radiation by nearly a mile of solid rock, scientists built colossal vats of ultra-pure liquid xenon. Xenon is a noble gas, remarkably stable, and when cooled to a liquid state it becomes incredibly dense. The interior of these detectors is the quietest, darkest environment on the planet. The tanks are lined with hypersensitive photomultiplier tubes, mechanical eyes capable of detecting a single solitary photon of light. The strategy was brutally simple. wait for a dark matter particle drifting through the underground cavern to strike a xenon nucleus. The impact would cause a microscopic recoil, generating an infinitesimally faint flash of light and a tiny release of electric charge. The experiments ran for years. The scientists watched the silent vats, waiting for the flash. They upgraded the sensors. They increased the volume of the liquid xenon, scaling up from kilograms to tons. They pushed the sensitivity of the detectors to the absolute bleeding edge of quantum mechanics, stripping away every conceivable source of background radiation, using ancient lead recovered from sunken Roman galleons because modern lead contains too many radioactive isotopes from 20th century atmospheric nuclear testing. They built the perfect trap for the phantom, and the detectors remained completely, terrifyingly silent. Zero flashes, zero collisions, zero proof. The WIMP theory, the most elegant and universally accepted explanation for 85% of the universe's mass, is slowly dying in the cold underground chambers of Italy. The dark matter is there. We can see its gravitational claws tearing at the fabric of distant galaxy clusters. We can measure how it bends the ancient light of the early universe through the process of gravitational lensing. But it refuses to interact with our detectors. This brings us back to the suffocating mystery of the missing transverse momentum and the fractured decay of the B mesons at CERN. If dark matter is not a heavy, sluggish WIMP that occasionally bumps into normal matter, then the rules of engagement are fundamentally wrong. The anomaly at the Large Hadron Collider suggests something far more complex and far more disturbing. The universe is not just hiding mass. It is operating under a set of invisible forces that we did not authorize in our mathematics. When the beauty quark decays and shows a bizarre, unexplainable preference for creating electrons over muons, it is violating the sacred symmetry of the standard model. This deviation, this microscopic leaning toward one side of the scale, cannot happen spontaneously. Something has to physically reach in and tilt the balance. Theoretical physicists, driven to the edge by these conflicting sets of data, have begun drafting new architectural blueprints for reality. To explain the broken symmetry, they are proposing the existence of entirely new fundamental forces. We know gravity, electromagnetism, and the strong and weak nuclear forces. But the data from the collider points toward a fifth force, mediated by a theoretical monstrosity known as a leptoquark. In the strict segregated hierarchy of the current laws of physics, quarks and leptons do not mix. Quarks are the prisoners. They are bound together by the strong nuclear force, trapped forever inside the nucleus of an atom to form protons and neutrons. You will never see a solitary quark. Leptons, on the other hand, are the free agents. The electron is a lepton. It orbits the nucleus, flows through copper wires, and dictates the entirety of human chemistry. They are two distinct, isolated families of matter. A leptoquark is a hypothetical bridge that burns that isolation to the ground. It is a massive, highly unstable particle that has the ability to interact with both families simultaneously, effectively allowing a quark to transmute directly into a lepton or vice versa. If this particle exists, it would completely rewrite the rules of subatomic decay. It would explain why the beauty quarks are behaving erratically. The leptoquark would act as an unseen thumb pressing down on the cosmic scale, momentarily bleeding energy away and forcing the decay process to favor electrons over muons. But a leptoquark is not just a convenient mathematical patch. It carries apocalyptic implications for the stability of matter itself. If quarks can spontaneously convert into leptons through this new force, then the protons that form the core of every atom in the universe are not immortal. They have an expiration date. Given enough time, the protons in the iron core of the Earth, the protons in the hydrogen of the sun, and the protons in your own bones would eventually decay, dissolving back into a wash of low-energy radiation. The solid universe would slowly evaporate into a cold, featureless fog of solitary electrons and photons. The missing momentum in the collider detectors, the bizarre asymmetrical decay of heavy particles, the overwhelming gravitational weight of invisible galaxies, the deafening silence of the underground liquid xenon tanks. These are no longer isolated scientific puzzles. They are a coordinated assault on the foundations of human physics. We are collecting pieces of a puzzle from different corners of the Earth, And as the image slowly begins to form, it resembles nothing we have ever seen before. The equations are breaking down, unable to digest the sheer scale of the anomalies bleeding into our reality. To fully grasp the magnitude of this impending collapse, we must confront the darkest, most closely guarded secret in modern theoretical physics. The human race possesses two separate maps of reality, and these two maps violently contradict each other. For a century, we have operated under a fragile truce between two warring mathematical frameworks. On one side, we have Albert Einstein's general relativity. It is a masterpiece of geometric elegance describing the macro-universe of gravity, the curvature of space-time, the slow, silent orbits of galaxy clusters, and the crushing depths of black holes. It treats the universe as a smooth, continuous fabric, a flawless trampoline bending under the weight of heavy stars. On the other side, we have the quantum mechanics of the Standard Model. It rules the microscopic domain. It is a chaotic, jagged, unpredictable world of discrete packets of energy, where subatomic particles pop in and out of existence, and nothing is certain until it is measured. We use relativity to navigate satellites and map the cosmos. We use quantum mechanics to build computer chips and lasers. Both maps work perfectly in their isolated domains. But if you try to lay one map on top of the other, if you attempt to use the mathematics of gravity to explain the behavior of a subatomic particle, the equations do not just fail, they violently disintegrate. When physicists attempt to force these two theories together to explain anomalies like the missing momentum at CERN, the mathematics return absurdities. The calculations produce mathematical infinities. They spit out probabilities greater than 100%, which is a physical and logical impossibility. It is the equivalent of asking a computer to divide by zero. Nature throws up a wall of mathematical static, refusing to allow us to see how gravity operates at the quantum level. We are effectively blind in the very domain where these new rogue particles must exist. The anomaly leaking from the beauty quarks exists exactly in this blind spot, a shadowy no-man's land where neither of our great physical theories functions. The profound frustration echoing through the halls of theoretical physics today is rooted in the death of a beautiful dream. For the past 40 years, the brightest minds on the planet believed they already had the solution to this paradox. It was an incredibly elegant mathematical framework called supersymmetry. Supersymmetry proposed a simple, comforting idea. For every particle we know about, there is a heavy, invisible mirror particle that we have not yet discovered. The equations of supersymmetry were breathtaking. They perfectly balanced the books of the universe. They explained the mass of the Higgs boson. They offered a perfect candidate for dark matter, and they smoothed out the violent friction between quantum mechanics and gravity. Supersymmetry was so mathematically beautiful that thousands of physicists devoted their entire careers, their entire adult lives, to studying it. It became the dominant religion of theoretical physics. When the Large Hadron Collider was first powered on, it was not just built to find the Higgs boson. It was built to flood the detectors with a heavy rain of supersymmetric particles, proving once and for all that our elegant mathematical models were correct. The collider smashed protons together for a decade. It reached energy levels no human machine had ever achieved. The detectors took trillions of photographs of the subatomic wreckage, and they found absolutely nothing. No mirror particles, no elegant symmetries, just the cold, barren void of the standard quantum vacuum and the nagging, asymmetric decay of the beauty quarks mocking our expectations. The absence of supersymmetry is arguably the most devastating non-discovery in the history of science. It means that the universe is not mathematically elegant, at least not in any way that the human brain evolved to appreciate. Nature does not care about our desire for symmetry. We built a $10 billion machine to confirm our grand unified theory, and the machine stared back at us and delivered a flat, uncompromising rejection. Now, we are stranded. We are facing a phenomenon we cannot explain, armed with theories that are fundamentally broken, and we are rapidly approaching a terrifying physical barrier in our engineering. To probe deeper into this anomaly, to try and catch a glimpse of the leptoquark or whatever unseen force is tilting the subatomic scales, we need to smash particles together with even greater violence. We need a bigger machine, But the laws of electromagnetism impose a brutal tax on our ambitions. It is a phenomenon known as synchrotron radiation, and it is the physical wall that threatens to end the era of particle colliders. When you trap a charged particle, like a proton, in a circular magnetic track and force it to travel at near light speed, it does not want to turn. Its own inertia demands that it travel in a straight line. The superconducting magnets of the collider must constantly bend the path of the proton, forcing it into a circle. But nature demands a price for this continuous acceleration. Every time the proton's path is bent, it bleeds energy in the form of intense X-ray radiation. It is like trying to drive a massive truck around a tight, icy curve at 200 miles an hour. The tires squeal, smoke billows, and the vehicle constantly fights to fly off the road. The faster you push the particles, the more aggressively they radiate their energy away into the walls of the tunnel. At the extreme energies required to tear the veil off this new anomaly, a circular collider the size of CERN becomes wildly inefficient. You are pumping gigawatts of electricity into a machine, only to watch the majority of it bleed out as waste radiation before the particles even collide. To overcome synchrotron radiation and reach the next frontier of physics, you cannot just upgrade the magnets. You have to build a wider circle. The curves must be gentler. To achieve the energies theoretical physicists now believe are necessary to force the hidden architecture of the universe into the light, we would need to construct a particle accelerator with a circumference of 100 kilometers. It would be an underground ring massive enough to encircle entire metropolitan cities. It would require an international budget that borders on the impossible and decades of excavation and engineering. And even if humanity pooled its resources to build such a colossal cathedral of science, there is absolutely no guarantee that it would find the answers. Nature could simply hide the next layer of truth at an energy level just out of reach of the new machine. We are playing a game of cosmic poker against an adversary with infinite chips, and we are rapidly running out of currency. This is the great paradox of our time. We have become too intelligent to accept the illusions of our biological senses, but we may not possess the engineering capacity or the mathematical language to grasp the true reality. We have successfully mapped the shorelines of the physical universe, but we are realizing that we cannot build a ship strong enough to sail into the deep ocean. If we attempt to bypass the mechanical limits of colliders by looking entirely to pure mathematics, we hit a barrier constructed by the fundamental nature of information itself. The Heisenberg uncertainty principle is not just a quirky rule about subatomic measurement. It is an aggressive defense mechanism of the cosmos. It dictates that there is a hard physical limit to how much information can be extracted from any given system. You can know exactly where a particle is, or you can know exactly how fast it is moving, but you can never know both simultaneously. The harder you try to pin down one property, the more violently the universe blurs the other. As we try to observe the infinitesimally small distances where this new fifth force might operate, where quarks morph into leptons and momentum vanishes into the dark, we are pushing against this ultimate resolution limit. We are zooming in on a digital photograph until the image completely dissolves into a chaotic grid of meaningless pixels. At the scale of 10 to the power of -35 meters, a domain known as the Planck length, the very concepts of space and time cease to have any physical meaning. Reality does not just become weird, it mathematically boils. In this microscopic inferno, known as quantum foam, the smooth trampoline of Einstein's relativity is shredded. Wormholes and microscopic black holes spontaneously tear themselves open and snap shut within a billionth of a trillionth of a nanosecond. Gravity and quantum mechanics clash in an infinite, chaotic war of fluctuating energy. It is a realm of absolute noise, a domain of reality so violent and turbulent that our current mathematical frameworks shatter just trying to describe its shadow. The missing momentum in our collision chambers might be a temporary visitor from this chaotic depth. The invisible force tilting the decay of the beauty quarks might be a faint, distant echo of a physics that operates strictly within this boiling subatomic architecture. We are trying to listen to a whisper from the basement of reality, but the sound is being drowned out by the roar of the quantum vacuum. We are trapped in a physical universe that demands to be understood, yet enforces a strict mathematical quarantine on its deepest mechanics. To understand the ultimate consequence of these fractures in our physics, you have to abandon the human concept of time. Our biological clocks are tied to the rotation of a single rock and the burning of a medium-sized, unremarkable star. We think in terms of decades, perhaps centuries, but the universe operates on a timescale so vast and unforgiving that human history does not even register as a microscopic footnote. If the anomalies detected in the supercooled tunnels of Europe represent a new framework of reality, if heavy, unseen forces are actively reaching across the subatomic divide to alter the decay of matter, then the long-term stability of the cosmos is an illusion. We are living on borrowed time in a temporary universe. The bedrock assumption of our existence is that the fundamental building blocks of matter are eternal. We rely on the absolute certainty that a proton, the heavy anchor inside the nucleus of every atom, will remain a proton forever. This permanence is what allows DNA to replicate, what allows planets to maintain their solid crusts, and what allows stars to sustain nuclear fusion for billions of years without spontaneously dissolving. But the introduction of a fifth force, a rogue mechanic that allows quarks to bleed into leptons, destroys this permanence. It introduces a fatal flaw into the architecture of everything you can see, touch, or measure. It means that matter has a half-life. Imagine an abandoned city in the middle of a desert at midnight. For a long time, the steel skyscrapers and concrete bridges stand tall, appearing completely invincible against the wind. But over millions of years, the chemical bonds in the concrete slowly degrade. The steel rusts at a microscopic level. There is no sudden explosion. There is no violent event. Just a relentless, agonizingly slow dissolution until the entire metropolis crumbles into a layer of featureless dust blowing across the barren rock. This is the fate of the physical universe if proton decay is real. In the deep cosmic future, long after the last stars have exhausted their nuclear fuel and flickered out, the universe will enter the degenerate era. The cosmos will be a lightless, freezing graveyard of black dwarfs, neutron stars, and wandering rogue planets drifting through an infinite void. If the current standard model holds, these dead remnants could theoretically persist indefinitely in the dark. But if the laws of physics are compromised by the hidden mechanics we are just now detecting, then even these dead stars are not safe. Trillions of years from now, the protons within them will begin to decay. The solid cores of frozen planets will turn into a mist of transient radiation. The heavy elements forged in the hearts of supernovas will quietly evaporate. Matter itself will cease to exist, dissolving into a cold, thinning fog of solitary electrons and stray photons, separated by billions of light-years of expanding nothingness. Yet, there is a scenario embedded in the mathematics of these anomalies that is far more sudden and far more catastrophic than the slow decay of protons. It is a concept known in theoretical physics as false vacuum decay, and it is arguably the most terrifying physical possibility permitted by modern science. To visualize this, you must understand how the universe assigns mass to objects. It is not an inherent property. Mass is dictated by an invisible universe-spanning grid called the Higgs field. You can think of the Higgs field as a cosmic ocean of water. When particles move through this ocean, they experience drag. That drag is what we perceive as mass. For the universe to be perfectly stable, this ocean must be at its lowest possible energy state, completely calm and resting at the absolute bottom of physical reality. We call this a true vacuum. But when physicists fed the mass of the Higgs boson into our cosmological equations, the mathematics returned a chilling result. The numbers suggest that our universe is not resting at the bottom. Instead, it is as if our cosmic ocean is trapped in a shallow crater halfway down the side of a massive cliff. It seems stable. It has been resting in this temporary depression for 13.8 billion years, allowing galaxies to form and life to evolve. But it is not a true vacuum, it is a false vacuum. The floor beneath our reality is incredibly fragile. If a microscopic fluctuation in the quantum foam, perhaps triggered by the very high-energy anomalies we are trying to force out of hiding, were to suddenly push a tiny region of space out of this crater, the floor would collapse. A microscopic bubble of true vacuum would be born. Inside this bubble, the Higgs field would drop to its true bottom, and the laws of physics would be instantly and radically rewritten. The mass of electrons would change. The forces binding atoms together would invert or disappear entirely. The chemistry that makes biology possible would instantly cease to function. This bubble of true physics would not remain microscopic. Driven by the energy released from the collapse of the false vacuum, the bubble would expand outward in all directions at the exact speed of light. Because it moves at light speed, there would be no warning. You could not see it coming. One moment, the solar system would be orbiting peacefully through the Milky Way, and in the next fraction of a nanosecond, a wall of pure mathematical deletion would wash over the Earth, erasing the solar system, the sun, and the surrounding stars, replacing our reality with a barren, unrecognizable universe where matter as we know it cannot exist. The missing transverse momentum at CERN is the ghost that haunts these equations. It is physical proof that the universe is capable of harboring mechanics that actively siphon energy away from our visible reality. If the framework of our reality is bleeding energy into unseen dimensions or hidden particles, the stability of the false vacuum becomes even more precarious. We are poking at the foundational walls of the universe with high-energy colliders, desperately trying to map the structural damage without accidentally triggering a collapse. Even if we avoid a sudden vacuum decay, the underlying mechanics of these hidden forces guarantee an inescapable freezing end. As the universe continues to expand, driven by the relentless repulsive force of dark energy, the temperature of the cosmos will continue to plummet toward absolute zero. The eventual rulers of this dying universe will be the black holes. For unimaginable eons, they will be the only structures left, silent leviathans hoarding the crushed remains of dead galaxies. But not even black holes are immune to the inescapable laws of thermodynamics. Through the bizarre mechanics of quantum mechanics at their event horizons, they will slowly leak energy back into the freezing void. The mathematics reveal a merciless truth. The smaller the black hole, the hotter it burns, accelerating its own evaporation into the void. One by one, across the incalculable stretches of dark time, the black holes will boil away in blinding flashes of hard radiation, leaving absolutely nothing behind. The anomalies we are currently wrestling with in the supercomputers of Geneva are not just quirks of high-energy physics. They are the initial clues to this final destiny. They tell us that the universe is not a perfectly sealed, eternally stable machine. It is a flawed, asymmetric system that is actively leaking, decaying, and transitioning toward an ultimate state of supreme entropy. Humanity has spent its entire history searching for a sense of grand purpose or intelligent design in the stars, but the data streaming from our most advanced machines tells a profoundly different story. We are a biological accident, clinging to a localized pocket of temporary stability in a cosmos that is hostile to structure, indifferent to life, and mathematically programmed to erase itself. The ghost in the machine is not a savior. It is the architect of the final silence. The human brain is a biological engine optimized for pattern recognition. We are neurologically wired to seek order in the chaos, to draw constellations out of random scatterings of burning gas, and to believe that the laws of physics are an eternal contract signed by the cosmos itself. We have spent our brief, microscopic moment of consciousness constructing monuments to our own significance. We built sprawling civilizations, mapped the orbital mechanics of our local planets, and buried 27-kilometer rings of supercooled niobium titanium beneath the bedrock of the Earth, all driven by the inherent assumption that the universe is a puzzle designed specifically for the human intellect to solve. We believed that if we just pushed the mathematics far enough, if we just smashed particles together with enough violence, the universe would eventually yield its fundamental truths to us, confirming our place at the center of the narrative. The shadow, lurking in the data at the European Organization for Nuclear Research, shatters that biological arrogance. The missing transverse momentum, the fractured symmetry of the beauty quarks, the crushing invisible weight that spins the outer rims of the galaxies, these are not mere gaps in a textbook waiting to be filled. They are profound, terrifying reminders of our fundamental exclusion from the true mechanics of reality. We are a localized, luminous byproduct, a temporary arrangement of unstable matter floating in a vast, dark ocean that operates on rules we were never meant to comprehend. The visible universe, the realm of light, chemistry, and solid ground, is a statistical anomaly. The true universe is dark, heavy, and silent. It does not exist for us to understand it. It does not operate on the elegant symmetries we demand. It is a cold, asymmetric, and relentlessly indifferent machine, grinding its way toward absolute entropy. When we stare into the supercomputers and see energy bleeding away into an unseen void, we are not just observing a breakdown in the standard model. We are looking directly at the boundaries of human relevance. The forces that govern the deep, invisible architecture of the cosmos do not care about the electromagnetic bonds that hold our DNA together. They do not care about the mathematical theories we write on blackboards, and they do not care about the fragile civilizations we build in the fading warmth of our temporary star. If the foundations of our physical reality are truly decaying, if the hidden forces we are just now detecting are actively tilting the subatomic scales against the survival of normal matter, then our long-term presence here is a physical impossibility. We are passengers on a microscopic vessel that is fundamentally incompatible with the deep waters it sails upon. There is a profound, paralyzing clarity in this realization. We are forced to abandon the comforting illusion that we are the ultimate observers of the cosmic story. The anomaly at the Large Hadron Collider is a whisper from the deep, telling us that reality is infinitely darker, infinitely heavier, and infinitely more alien than our equations can ever describe. We have reached the edge of our biological and mechanical perception. We have meticulously mapped the tiny illuminated island of our physical world, and now we are standing on the shoreline, staring out into a freezing, impenetrable fog that defies our logic. Eventually, the cosmic clock will run out. The remaining stars will exhaust their nuclear fuel, turning the galaxies into silent graveyards. The supermassive black holes will slowly boil away into the vacuum. And if the heavy, invisible mechanics we are wrestling with today dictate the ultimate fate of matter, the very protons that make up the dust of our ruined worlds will quietly dissolve. The grand, physical architecture of the cosmos will erase itself, transitioning into a limitless expanse of featureless cold, with no light, no warmth, and no conscious minds left to witness the end. The universe will forget that we were ever here. The physical ledger will be wiped clean, and the void will return to a perfect, eternal silence,